everyone. Yeah, my name is Gabe Lenetsky. I'm a business development lead here at Keysight, and I'm representing our quantum engineering solutions team. And I'm here to explain to you why Keysight is at the heart of your quantum revolution. So in my talk today, I'm going to go over who Keysight is, what is our history in quantum and quantum computing, who we have helped enable with our potential customers, such as Google, at the Google Quantum Testbed, Blueforce, and as well as the, and others that I'll go over today. So, there we go. So Keysight Technologies is at the heart of the quantum revolution. We're built on the backbone of 80 years of experience of electronic design and test and measurement. It was originally founded by Bill Hewlett and Dave Packard of HP. So we have a lot of experience and knowledge in design and testing, and as well as a network of trusted hardware, innovative software, and global network of experts. So Keysight, as of 2022, has 150 locations. It has doing business in over 100 different countries around the world. We have over 14,000 employees, and we have an ASIC design center and proprietary fabrication facility based in Santa Rosa, California. And we have over 40 service hubs where customers can where we can help our customers with their hardware if they have any issues with them. So here is Keysight compared to our peers. So Keysight went public in the year of 2015, and you can see how we've stacked up against the S&P 500. We've done a lot of work in innovating technologies in 5G, space and satellite, and other networking. And we've been crushing it in terms of records, and so don't let that downturn fool you there. Moving forward into our path in quantum, it originally started with an acquisition of a company called Signadyne, which creates AWGs, arbitrary waveform generators, and digitizers in a PXI mainframe. And this is being implemented on trapped ion quantum computers as well as spin qubits and superconducting qubits. And in 2018, we joined QEDC as a founding member in the Quantum Economic Development Consortia. And in 2018 as well, we began collaborating with the Boulder Cryo Quantum Testbed, which I'll get into a little more depth later on. And then in 2019, we acquired a company called Labber Quantum, which is a software company based out of MIT that focuses on creating solutions for quantum computing. And in 2020, we built out our quantum research center near MIT in Cambridge, Massachusetts. 2021, we acquired a company called Quantum Benchmark, which is a error diagnostics and error mitigation software platform, which I'll go over a little more in depth later in the talk today. And then in 2022, we announced our collaboration with MIT, the Engineering Quantum Center, on their 64-qubit testbed. So here's an overview of Keysight's quantum team footprint. So I'm based in Santa Rosa, California. We have a lot of folks based in Colorado, as well as in Cambridge, Massachusetts. So a lot of focus in North America. But worldwide, we have other folks based in Sweden, Germany, Barcelona, Spain, and more. This is just the quantum team, but we have more engineers and other solution experts involved in different industries as well. And as well as in Japan. So to get in depth about one of our collaborations here with the Boulder Cryogenic Testbed, this was a collaboration between the University of Colorado, Google, and NIST. And the goal of this project was to develop a methodology for characterizing resonators. And the collaboration involved Keysight providing a network analyzer. That's a picture of one of our VNAs right there that was used with the research engineers in the lab with the dilution refrigerator to characterize the resonators. So we think there's a lot that still needs to be done in the standardization of a lot of the quantum devices that are being built and researched today. So this is an example of what was the result of this collaboration. So there's the PNA sitting in the lab. There's the dilution refrigerator. There's one of these students that we worked with. And the goal and the end result of this collaboration resulted in this academic paper of a single port calibration for superconducting microwave resonator measurements. So this is key to the researching community that are looking at ways to better design quantum computers down to the devices under tests. So I'd mentioned Keysight is a part of QEDC, and QEDC is an international consortia now involving Japan and other countries in EU and Australia regions. One of our directors here at Keysight, part of our quantum engineering solutions team, is Eric Holland. He's on the steering committee. So we're doing a lot of focus and work there with the QEDC in helping build up the quantum computing community. So we talk a lot about collaboration here at Q2B. This is a collaboration that we've done with Blue Force and their dilution refrigerator engineering team. So this collaboration involves our hardware and software working with their team of experts who design the dilution refrigerator schemes in order to do the types of measurements that are involved in quantum computing, like T1 measurements or the drive frequency measurements. So this is our this is our Labber software, and this is our Keysight control system right there. And so the result of this collaboration has created a seamless knowledge transfer to the quantum supply chain. And if you'd like to find out more on this, you can please go to keysight.com/find/quantum. So I talked about that there's still a lot of need in the cryogenic component characterization. So the challenges today is that there's an in situ cryogenic calibration method that was required to isolate the individual DUTs, devices under test, from the cryostat wiring. So you can see in this academic paper here, also with NIST, NIST Boulder, the Keysight network analyzer doing a one port measurement, but you have all these attenuators down to the devices under test. So how do you understand if you're characterizing your quantum devices correctly? And the solution that we came up with working with NIST was a one-port SOL S-parameter measurement, where we're removing all this excess stuff down to the device under test in order to get correct, accurate measurements of the qubits. So it's just one step that we're trying to help the community with making a more standard understanding of quantum devices. So there's more to our collaboration efforts. We're doing some work with FormFactor, which is a dilution refrigerator cryostat company. In this case, we've collaborated with them using our qubit control systems and Labber to make a more turnkey qubit pre-screening solution for superconducting and spin qubits, two of the major candidates in quantum computing. And so the result of this collaboration has generated a more automated, fast qubit tune-up and characterization of these devices. So the challenge today is that quantum computing is somewhat time-consuming, especially in the R&D phase, which we are in today. So in order to accelerate this process, we've come up with a more automated solution where you can measure your resonator frequency, power, qubit frequency, all the way to finally characterizing those devices. So it's just one way that we're trying to help strengthen this phase of quantum computing. So I'll talk a little bit now about our footprint in Japan. So we've done some work with several of the universities and national labs today. This is a paper that uses, that we worked with Riken on. It's the real-time feedback control of charge sensing for quantum dots. And the purpose of this research was to use a Keysight combo card, which is a PXI, AWG, and digitizer, which has a FPGA built on board. And working with Keysight and the customer at Riken, we were able to develop a feedback loop, a PID controller that makes it easy for this lab to characterize their quantum dots and do things like charge sensing. And we have done a lot of collaboration work with Fujitsu as well. This is some work that we've done with our quantum benchmark software called TrueQ. So TrueQ is, like I said, it's error diagnostic tools or error mitigation tools. And so there's work we've done with Grover's search algorithm and quantum chemistry applications using TrueQ's random compiler, which will improve the performance. So you can see here these two bars that show with and without RC the improvements that the measurement was made, how the measurement was made. And then furthermore, on this 10 qubit experimental data of AQT's Pine on a trapped ion device. So this TrueQ software is very powerful, and it can help do things like help remove that excess noise and show that error mitigation can significantly improve the accuracy of these more useful quantum applications. Furthermore, with some of the national labs here in Japan with AIST, they have used Keysight Network Analyzer to do things like characterizing quantum devices, in this case, adiabatic quantum flux permetrin logic, and using our tools for the purpose of that research. So MIT, with their 64-qubit testbed, I'll just say that we're working closely and using our control systems in their lab as well as our network analyzers. So this is a quote from the leading professor, William Oliver, who is the director of the Center for Quantum Engineering at MIT. So early access of Keysight's technology has been key to enabling our research for the past few years. EQUIS looks forward to applying Keysight's emerging quantum software and hardware solutions for our new 64-qubit testbed. So the importance of collaboration here is helping drive this research. And so I'm proud, and we're all proud at Keysight to announce our new quantum control solution. I'm giving you a little preview of it here. This is what the new system looks like. It's a new PXI chassis with improved cooling technology and higher power in order to drive these AWGs at higher frequencies for superconducting and spin qubit applications, and as well as using a new down converter and a digitizer for doing control and readout experiments. And this is all powered by this QCS API using Python in order to give our customers the full control of our hardware. So I said it'd be a preview. Please come to a more in-depth talk tomorrow during the QC track, presented by Kenji for pushing the envelope in quantum through key innovation. So just to give you all a preview of our roadmap, this is where we're heading. So we've done a lot of focus in building our hardware, and now we're trying to bridge the gaps between what would be TrueQ software and our pulse sequencing API. So currently today, we have a circuit API which runs gates and cycles using TrueQ. We're working on bridging that to more common quantum languages like Qiskit, Cirq, Pikewill, and Chasm. And then in order to bridge this gap to give our collaborators the full control throughout the full system, we're working on this pulse sequence API in order to generate more unique waveforms for things in the waveform-based backend as well as the primitive-based backend. So that's something that we're working on, and if you have any interest in this, you can talk with me later at our booth about this. So there's a lot that is in hold for Keysight. We're not just looking at the control and software side of quantum computing, we're also looking at the full design workflow. So going from an early prototype quantum device all the way to that being deployed or manufactured. So designing a quantum control workflow, I think, is critical to the accelerating this area. Doing this in design and simulation. So we already have a lot of experience in semiconductors, so in semiconductor design. So we're trying to bridge that gap between quantum and what we know today in order to create more centric solutions for quantum computing. We want to definitely be part of the quantum computers. So this is an example of how we can use our quantum control systems in a way that is more scalable to achieve the goal of reaching to hundreds or even thousands of qubits. And so, like I said in the previous slide, we're trying to bridge that gap in order to climb this stack to make it the quantum control systems more centric for our users. So a few final thoughts here today. Keysight is committed to the collaboration and innovation to accelerate quantum technologies. Please attend this talk tomorrow, Keysight Pushing the Envelope in Quantum Through Key Innovation, presented by Kenji Kikuchi. Please come visit our booth and meet all our Japanese team. And I'll be there and you can come talk with me. And if you have more questions or things like that, you can reach out to us on LinkedIn or Twitter at Keysight Quantum Engineering Solutions or at KeysightQ. So thank you for your time today.